Hey guys, hope everybody's doing okay. What we're going to do today is go through and solve a limiting reagent practice problem. So this might be the first time you're ever doing one like this, or maybe we did some in class and this is a review video that you're watching. But either way, it's good to see the process that we go through so you can mimic that process as you try to do some of the practice problems on your own. So we'll start out by looking at a hypothetical situation on the screen, which is substance A plus substance B produces the compound AB. Now, normally our introductory or basic stoichiometry problems, I would give you an amount of A, and we would assume that letter B, substance B, is in excess, and we could figure out how much AB we could create. Or maybe I give you substance B, and we assume substance A is in excess, and we can figure out how much substance AB we could create. So there was always something in excess that we made that assumption for. But sometimes that's not going to be given to you, right? You know there's going to be something that is in excess. Reactions very rarely run out of all the reactants at the same time, right? So a limiting reagent problem is when you're given specific amounts of two or more reactants. You have to go from there. So let's just hypothetically say I have X grams of substance A and Y grams of substance B. Now I need to figure out, is substance A or B going to run out first? Whichever one runs out first is my limiting reagent, right? And the reaction comes to a stop, and I can't make any more product. So here's the general game plan. If you're given an amount of two things, right, two reactants or more, you want to take one at a time. So let's say we have our X grams of substance A, do some stoichiometry, and see how much product you could create from that. Let's pretend it's 3 grams. And let's say I take my Y grams of substance B, do stoichiometry, and convert that into an amount of AB. How much product could I make from that? Let's pretend it's 10 grams. Okay, so what's this mean here? It means if I have X grams of A, and I'm assuming I have excess substance B, all right, I can make 3 grams of product. If I have Y grams of substance B, and I assume excess substance A, I could make 10 grams. Okay? So if I take a look at this, what's going to limit how much AB I could produce? Well, it's going to be substance A. So substance A is going to be our limiting reagent. Okay? Substance B is going to be our excess reagent. All right? So that's the general game plan for how we want to approach something like this. It kind of goes back to our s'more example that we did earlier. You have a chemical reaction, right? And if you had, I don't know, you had 10 graham crackers and 2 marshmallows, I don't know, and 1 piece of chocolate, how many s'mores could you make? Well, based off of your graham crackers, you could make 5 s'mores because you need 2 graham crackers per s'more. Based on your marshmallows, you could make 2 s'mores because you need 1 marshmallow for every s'more. And based on your pieces of chocolate, you have 1. You can only make 1 s'more, okay? Just 1 piece of chocolate per s'more. So if you have all those ingredients, you only still could make 1 s'more, right? So look what we did. We said we can make 5 from our graham crackers, assuming everything else was in excess. We can make 2 from our marshmallows, assuming everything else was in excess. 1 from our chocolate, assuming everything else was in excess. And therefore, the chocolate is going to limit you to 1 s'more. So this would be our limiting reagent, and you would have excess graham crackers and excess marshmallows. So let's go ahead and look at how this applies to a bigger practice problem. So we'll keep revisiting our stoichiometry roadmap to make sure we're okay with that. This is going to be in your packet if you go to the back on the practice test number 4. So let's take a look at how we do a problem like this, where we have iron 3 oxide plus carbon producing iron and carbon monoxide. It's already balanced for you. And what we want to do here is read the problem, right? And we want to put this information above under our equation where it goes. All right, so let's go ahead and do that. We have a 250 milliliters of 4 molar iron 3 oxide solution. Okay, so that's the information about the iron 3 oxide. So when I see milliliters here, I automatically go in my head, let me just change that to liters right off the bat. So I have 0.25 liters, and I have a 4.00 molar solution. Okay, so again, I always organize my work here, and you want to do the same thing. So go ahead and do that and label those. And then let's take a look at what else we have. It says it reacts with 25.0 grams of carbon. So let's go ahead and label that. All right. Let's keep reading the problem. It says how many grams of carbon monoxide will be formed. Okay, so we want to focus on carbon monoxide here. That's our product that we're looking for. So what you want to do, and it's just what I do on the screen here, it's so easy to organize your work this way. You want to figure out, now we have two reactants here, right? So I need to figure out which one of these is going to run out first. I'm going to have a limiting reagent here. And once I figure out which one that is, then I know how much carbon monoxide I could make from this. So I need to figure out from my 25 grams of carbon, how much carbon monoxide can I make? From my 4 molar and 0.25 milliliter solution of iron 3 oxide, how much carbon monoxide can I make? Okay, it's exactly what we did here. I took my amount of A and I figured out how much AB I could make. We said it was 3 grams. I took my amount of substance B, I figured out how much AB I can make, it was 10 grams. Then I figured out what my limiting reagent was going to be. All right, that's what we want to do here. So get a game plan, just like I have on the equation here, and then let's go ahead and start solving this thing. All right, so let's go ahead and do the iron 3 oxide first. Let me get back to my color coding here. So if you're on your roadmap, you have a molarity right here. Okay, you have a molarity and a volume of one substance. And I want to go to, if I look at the problem, it says how many grams of carbon monoxide. So I want to go to mass of B. All right, so if you follow the roadmap, I want to go here, here, here. All right, so the first thing I need to do is get to my moles of substance A. All right, and that's going to be moles of Fe2O3. So let's go ahead and do that. If I have, let's do factor label here. But remember, molarity equals moles per liter, right? So I have a 0.25 liter solution. I want to cancel out liters and go to moles. Okay, and if you look at right here, this goes way back to a couple units ago. There's my moles per liter. Okay, that's my conversion factor here. And I could put my 4.00 and 1. Remember, you could unpack that molarity. So 4 molar equals 4 moles over 1 liter. Right, and you could flip that if you needed to based on how your factor labeling is going. Okay, I'm being sloppy here. I'm not putting my units in, and that's bad. Okay, but I'm kind of running out of space here. It's hard to write with the stylus. So I'm here right now. Okay, now I need to go to moles of substance B. I know what substance B is because I did my scratch work up here, and my arrows are going to carbon monoxide. So I'm going to start incorporating my units here, and you should have had them earlier as well. But I want to cancel out moles of Fe2O3, and I want to convert to moles of carbon monoxide. Okay, and then I need to go here. Okay, I'm here now. I want to go down to here. So I have to go from moles to mass, and we know how to do that. I want to cancel out moles of carbon monoxide. I want to go to grams of carbon monoxide. Okay, let's go ahead and fill in our information here. So when we have the step in the middle, if we remember from our intro to stoichiometry lesson, this step right here, where you have your mole to mole ratio step, that comes from the balanced chemical equation. So in the balanced chemical equation, I have 1 mole of Fe2O3, and I have 3 moles of carbon monoxide. All right, and then everywhere else, I don't use those molar ratios. So out here, I put 1 next to moles of CO. I look up I calculate the molar mass, which I did over here on my answer key, and my molar mass of carbon monoxide is 28.01 grams. All right. So we go ahead and cancel our units, figure out what our answer is, and this gives us 84 grams of carbon monoxide. So what's this mean? It means my starting conditions of iron 3 oxide, Fe2O3, when I start with 25 or 0.25 liters of 4.00 molar Fe2O3, I can create 84 grams of carbon monoxide. Now, what I want to do is figure out, based on my 25 grams of carbon, how much carbon monoxide could I create? So let me go ahead and do my other stoichiometry problem, which is going to be down here. So let's start with our 25.0 grams of carbon. Okay, so now, let me erase this real quick. On my roadmap, I am here. Okay, I have my 25 grams of carbon. I still need to solve for grams of carbon monoxide. So I need to go 1, 2, 3. All right, so I need to convert to moles of A, then moles of B, and then mass of B. Let's go ahead and do that. We know how to do all these. This is a simpler calculation because there's no molarity involved. I'm going to cancel out grams of carbon and go to moles of carbon because that's my substance A. All right, and then I want to go into moles of substance B. And I know what that is because I did my scratch work up here. Substance B is carbon monoxide. So I'm going to cancel out moles of carbon, and I'm going to convert to moles of carbon monoxide. Look at the last step. It's basically the same. I want to cancel out moles of CO, and I would convert to grams of CO. All right, so you go ahead, let's fill our numbers in now. My molar mass of carbon is 12.01 grams per mole. And now I have to look at my middle step, so I'm going to go ahead and try to keep this same colors as before. I don't know which one I had. We'll pretend it's that one. So here we are. Okay, I have mole to mole ratio step. So again, I go to my balanced chemical equation. In my balanced chemical equation, I have 3 moles of carbon and 3 moles of carbon monoxide. And I have some students that are like, well, it's just going to be 3 divided by 3, that's 1. I'm not going to include that step. You cannot do that, all right? You can't magically just convert from moles of carbon into grams of carbon monoxide, or, you know what I mean? Like you have to show how you got there. You're getting there by canceling out the moles of carbon here, okay, to convert to moles of carbon monoxide. So this step is required no matter what, even if it is something like 3/3. It has to be there. That's how you're showing me, or anybody, that you're going from substance A to substance B. This step right here. Okay? That's the only way to get from one side of this roadmap to the other side of the roadmap. All right? Let's finish it off by putting in the information for the last step, which is the same as above. 1 mole of carbon monoxide is 28.01 grams of carbon monoxide. Go ahead and do the math, and you get 58.3 grams of carbon monoxide. All right, so now we want to make sure we answer the question, and we talk about this a little bit. It says, how many grams of carbon monoxide will be formed? So you have 2 numbers here. If I have 25 grams of carbon, and I assume I have excess everything else, I could only make 58.3 grams of carbon monoxide. And again, back up to the top here, if I have 0.25 liters of 4 molar iron 3 oxide and excess everything else, I can only make 84 grams of carbon monoxide. So clearly, you're going to produce 58.3 grams of carbon monoxide. All right. The carbon is your limiting reagent here. So what we want to do is keep everything organized. The question asks you, how much carbon monoxide can you form? Well, there you go. Your answer is 58.3 grams. That's the end of the story. But the limiting reagent then, because usually the problem will say, what is your limiting reagent? Students always get this wrong. The limiting reagent is not 58.3 grams of CO. That's how much you made, okay? The limiting reagent is what you ran out of, okay? A reagent is a reactant, okay? So your limiting reagent or reactant has to be on the reactant side of your chemical equation. So the limiting reagent in this case is carbon. Okay? The excess reagent is what you have left over. It's the other stuff. In this case, there's only one other thing. It's the iron 3 oxide. All right? What we can do is calculate how much excess we actually have left over. Okay? I'll do that example in class, but what you can do is you can take your information from this step. So basically, once we do this, we don't really want this information anymore, okay? Because that's our excess, right? We know we're limited by the carbon, and we can only make 58.3 grams of product here. What we can do is take either this number, okay? We could take either the 25.0 grams of carbon or the 58.3 grams of carbon monoxide, because I know I used up all that, and I know I'm making this. I could take that and convert it into Fe2O3, all right? And that'll tell me how much Fe2O3 I actually used to either react with this or to make this. Okay, this is really, really powerful. You could learn a lot and know a lot from stoichiometry problems. You could figure out anything you want. You could figure out how much stuff you're going to make, how much stuff you need to make something. You could convert from one thing to something else in this chemical equation. Like, pick anything you want, okay? And just know that reactants combine to create products. That's all you got to know. And then follow your mole roadmap. You can figure out anything you want from this. All right, so that's our not so quick practice problem on limiting reagents. I might have you try one and see how you do on it. And then when we're in class, we'll get more review on this or another lesson on this, and we'll be able to do some more practice problems. Okay? All right, guys, that's really about it for today. Thanks.